Know the different types of vaccines. We talked about the mRNA vaccines, an attenuated versus an activated. Know the different types of vaccines we talked about, how they work. Know the different kinds of immunizations we talked about, like active versus passive, natural versus artificial. Know the different antibiotics we talked about, the different classes and how they work. Understand herd immunity. Understand minimal inhibitory concentration. Some more questions about vaccines of different types. Understand, and we did this on the quiz today, but understand like zones of inhibition, how you measure them. So you measure like the diameter, the bigger, for this is, I'm giving you a very simplistic explanation of this, but the bigger the zone for the most part, the more sensitive it is to that antibiotic. The smaller the zone, the more resistant it is to that antibiotic. For the different vaccines I talked about, make sure you understand what kind of vaccine it is. So like the whooping cough vaccine, well, it's actually going to be different. So like, let's say, like the polio vaccine. So the polio vaccine we give in the United States. You remember what kind of vaccine that is? Yeah, it's inactivated. So remember, like, be able to kind of match up, just for the vaccines we talked about, like what they are. So remember there is an attenuated one too, we just don't give it in this country. So like the United States, like the polio vaccine is an inactivated vaccine. If it's inactivated, there's no chance of you getting that type of infection from it because it's not functional anymore. If you give an inactivated vaccine versus an attenuated vaccine for something, which one do you need boosters for? Inactivated, because it doesn't, whatever you inject, that's what they get. They don't get any more of that. If you give them an attenuated virus or bacteria or whatever, it's a weakened strain, but it will grow more. If it's a virus, it will replicate more make copies of itself. So it's like an internal booster. So usually for the attenuated ones, you don't have to necessarily give a booster. The inactivated vaccines, you're probably going to be given a booster. The cellular ones, you're probably given a booster. Yeah.
Why do you no longer get the attenuated vaccine?
The attenuated for polio, because there's people that get polio from it. I mean, that's really the only reason. There was a guy, I cannot remember what his name was now, but essentially he took polio vaccine, got polio, lobbied the Congress around 2005, 2006, and then Congress was like, this is stupid, people are getting the disease from the things we're trying to keep. The thing we're giving them to try to prevent them from getting that disease, so let's just not use that one anymore. Yeah.
I don't know, now I'm just thinking like for the polio vaccine, did I get the attenuated one? Like if I was
We all did. Yeah. We would have got the no, sorry, we would have all got them activated.
When did they stop giving them?
It was 06. Depends on when you were born. So I would have gotten the attenuated.
That's what I'm just wondering.
Don't have polio, right? We're good. So depending on when you were born, yes, you would have got the attenuated. Like our kids, like my kids would have got the inactivated, but I would have got the attenuated. And last time I checked, I don't have polio, so that's good. No polio, yay. You will probably see cases of polios and different things because of vaccine hesitancy, so people not taking vaccines. Those are diseases that unfortunately in your lifetime you're probably going to see a lot more of. And I wish I was not telling you that, but I'm just trying to be honest. Understand vaccines. Understand therapeutic index. We talked about that. We talked about correlates of protection as a concerning vaccines. We can with that. understand what we kind of did on that quiz today, because we talked about that stuff in lecture 2. So if you have, say, an antibiotic you're testing, and you have like a zone of inhibition around the antibiotic disc, and you take a sample out of that zone and you put it in a test tube that has bacteriological media in it, and bacteria grows. Was that drug bactericidal or static? And if it doesn't grow, cycle kills it. So be familiar with that, because we talked about the same thing in lecture. The antibiotics we talked about, make sure you know the mechanisms of action. Does it inhibit cell wall? Does it inhibit protein synthesis? Make sure you can match them with what they do, what the mechanisms of action are. I already told you this, make sure you know the different kinds of vaccines. Like there's a question on here, like asking 1 to 10 which vaccine is. I think probably we're going to get that. But there's definition stuff on here like that. Bactericidal versus bacteriostatic. We talked about this, but I'll ask you this one. What percentage of the population, just speaking very broadly, do you have to have in the population? Like how many percent of the population need to be vaccinated typically to have herd immunity? Okay, well, I guess I didn't have to figure it out. Okay, cool. I guess good job. Again, understand therapeutic index, there's a couple questions on there. I touched on this a little bit today, I think I mentioned it when we talked about the antibiotics too. But if you have an antibiotic and you add a functional group onto it, like we talked about these different heavy metals and stuff tonight, if you add a functional group onto it, it can change the activity of that antibiotic. So just know that. And also is if you have antibiotics that are very similar in structure, the chances are the more similar in structure they are to one another, the more likely they'll have a very similar mechanism of action. We didn't actually I don't think I exactly specifically worded it like that to y'all, but just so you know. Another question about herd immunity. Know what the TD50 is. I know what that is. Again, there's some questions on here too. It's like, oh, this is the vaccine. Like, is it acellular? Is it attenuated? Is it inactivated? Should be able to kind of match them up for the ones we talked about. You remember I talked about something we usually refer to as combination therapy? Anybody remember what combination therapy is? Can you tell by antibiotics?
Is that what they do with like TB and like a lot of them?
So you give more than one antibiotic because whatever organism you're trying to treat has problems with drug resistance, and you give them multiple drugs that have different mechanisms of action. If they have different mechanisms of action, chances are that the microorganism is not going to become resistant to all those different drugs with different mechanisms of action. If you give things like tuberculosis and treat them with one antibiotic, the vast majority of the time, there's some kind of random mutation and it becomes resistant to it. But if you treat those kinds of organisms like tuberculosis with 2 or 3 different drugs that all have very different mechanisms of action, the chances of that Mycobacterium tuberculosis randomly having 3 mutations that make it resistant to all 3 of those drugs is infinitesimally small. Like that does not happen very often. So that's what combination therapy is. I will go ahead and give you this one question. This is from the Applied Microbiology lecture. It says, number 36, in applied microbiology, microbial products can be improved by A, modifying culture conditions, B, mutating existing strains, C, isolating new strains, or D, all choices are correct. Remind me, I'm going to give you the answer for that one when I give that to you because I don't like that question at all now. So don't worry about that one. We'll get that one.
So you want to do it for that?
what it's supposed to be, and I'm not seeing the,
Will you also let the doctor services know that?
yes,
Okay.
I can do that. In fact, I'll write myself a note for that right now. Because that is the only question that is 100% from the applied microbiology lecture. And what the choice is supposed to be on there is supposed to say alter functional groups, which I don't see as a choice. So we will take care of number 36. Now, adaptive services. Now, number 36. What I'll do for that one is probably when I print out the exam, and I send it to adaptive services, and then when I get here, I'll just literally highlight that answer to that one. Like it'll be C or B, or whatever fits on my key. So don't worry about that one. Understand like broad versus narrow therapeutic indices. So remember there's a narrow therapeutic index, the toxic effect of the drug versus the therapeutic effect of the drug on the bacteria. If they're really close to one another, where it hurts you and it hurts the bacteria, those are not very friendly drugs usually because they have a lot of side effects. So the more narrow that therapeutic index is, the more problems you're going to have. Understand quorum sensing. Understand the difference between broad spectrum and narrow spectrum. So what's a narrow spectrum antibiotic? What's that mean?
These are target specific.
Yeah, like it used to treat TB. Broad spectrum used to treat like all gram positives. So narrow versus broad. There's some more questions on here about what the mechanism of action is for some different antibiotics, like does it disrupt protein synthesis, does it block cell wall synthesis. Some different things on here about like understanding what an activated vaccine is, a passive vaccine, RNA vaccine, DNA vaccine, using vectors for vaccines, live attenuated vaccines, knowing what an adjuvant is, knowing when you need boosters. We talked about that a little bit already. There's a bunch of questions here at the end about different mechanisms of actions for different kinds of drugs, penicillin, polymyxins, quinolones, all kinds of different things. Again, that mechanism of action for the drugs we talked about. And then there's essentially questions 67 to 75 around this lecture group tonight. So not that many. And again, they're mostly definitions, knowing like kind of how bioforms form, what mineralization is and fixation and nitrification, denitrification, and fixation. It's a lot of terms, mostly. Understanding biomagnification, like we talked about. Knowing the different kinds of relationships we talked about, commensalism, parasitism, predation, mutualism, knowing all those. And that is up to 75. Okay?